Okay, I think it is now time to start. Can everybody hear me? I, everything good? Give me some kind of thumbs up. Yeah, I'm seeing vigorous nodding. That's good. Okay, so I'd like to welcome everybody to the first quote unquote real lecture in 519, the data science class. Are there any questions about the homework, about the quizzes? First, did the quizzes go successfully? Or were there any problems? Did any people have any trouble with the quizzes that technically or logistically that I should know about? Okay, so that's hopefully going to be the case for the rest of the semester. Every class before the beginning of class, kill the quiz. It's just designed to keep you fresh in mind what was going on in the previous class. Any other questions that came up that from someone about the course before we go on any further? Okay, one thing I want you to warn me about is last class, in another one of the courses I was teaching, my computer my tablet kind of crashed and what was on the screen started seeming weird. And if that starts to happen, I need to get feedback from you guys and maybe I can try to figure it out. Okay, any questions? Okay, so what I'd like to do is, again, this is, I'd like to say is my official, what is data science lecture, or how are you supposed to think about data science? And as we talked about before, there's a couple of ways you can think what data science is. I like to think of it as something at the intersection of exploratory data analysis and visualization. And machine learning / statistics and different computing technologies. But there are other ways of thinking what data science is, although all of them seem to involve the intersection of three things. This is a figure that I kind of like, which shows that what happens when you have different subsets of computer science, statistics, and domain knowledge. Okay. Most of you, I will claim, have been software developers and lived only in the hacking skills area to some extent. We don't want to fight with that. At kind of machine learning is kind of at the intersection between statistics and data and computer science. I think I can believe that. Researchers in areas like science and the social sciences and things like that usually were people who knew their domain science, and research typically involves some knowledge of the domain and some formal math and statistics. Data science is kind of at the intersection of all three of them, whereas you get into trouble if you know a little bit of programming and a little bit of domain and you don't know how to think statistically. So anyway, so this is another picture of kind of what we are doing and how we live, and maybe it's helpful. And again, if there are any questions or comments, I'd like there to be people to come back. In fact, a lot of the stuff that I'm going to talk about today is, I will say, editorial opinion, sort of a little bit of opinions, feelings about how this goes. If this starts a discussion, this is a good thing. Okay, so don't be afraid to push back if you feel you disagree. I'd like these to be discussion things. So one thing that I have found, one reason why I go through this at the beginning of the semester is I don't think that computer scientists naturally are trained to appreciate what data is. They're trained to appreciate algorithms. They're trained to appreciate that there has to be an input file that is feeding into what their program is doing. But they don't really tend to appreciate that data is a hard thing to get. And I guess my favorite example of this is, how many of you have ever, for an assignment or something else, had to test how efficient an algorithm is? And so you took it and you ran it on random numbers, random data. Any people who ever have to do that? Okay, I see some people twitching, so that's good. Okay. Now, when I tell this to scientists, they are actually aghast. They say, you people, you computer scientists, what do? You take a program and you run random numbers through it. Do you look at what's coming out? No, all you're caring is how fast it is, okay, or whether it gave you the same answer as some test file. There's a difference between kind of the input being random and data sets that require large amounts of work to get. You know, some of you are going to have colleagues here, other graduate students in the life sciences, in, you know, the social sciences. If you talk to what they do, they spend their life struggling to get data. They sleep by their experiments at night, and they get small numbers of data points. And the reason is because the data is kind of an important thing, okay? And that's kind of a culture that we've got to assimilate. So what I found, again, over the years, I've worked a lot with people from other disciplines. And there's a difference between, again, how computer scientists see the world and how, I'll say real scientists see the world. Okay, one thing is that real scientists are trying to understand a world that it exists, okay? And they didn't design it, they didn't, they basically want to understand what's out there. Whereas computer scientists insist on virtual worlds, complete things that are defined. Back in my day, people used to program computers. You guys now program virtual machines, right? You're not even programming on a real machine anymore. It's something in a cloud, and it's maybe not even a machine. It's a part of a machine, okay? This is fine, but recognize that there is a difference. One consequence of it is that in an experimental science, nothing is ever completely true or false. Okay, when I work with my biologists, I will be often asking them, they'll tell me how some gene regulates something else. And I'll say, is that how it works? And they'll say, yeah. And then I'll ask them, is that how it really works? And they'll say, well, there's alternate pathways. Sometimes something else happens. The world is complicated. It's not completely true. Whereas in computer science and mathematics, everything is pretty much true by definition. Okay, and this requires some kind of a culture, because when you're using data for something, you are living in the scientist's world. Okay. One other thing, as I've said, is that real scientists tend to be data-driven, whereas computer scientists are still culturally algorithm-driven. It's a little bit different, maybe in the era of machine learning, but I still think that that's true. One other thing that I find, again, doing research with people, is the scientists are obsessed with discovering things. If you say, what does a real scientist do? They make discoveries, okay? Whereas what do computer scientists do? Well, we tend to make inventions. We tend to create programs. We tend to create algorithms. There's a difference between creation, which is kind of an engineering kind of a mindset, and discovery, which is like a science mindset. And I find it kind of interesting. When you're working with scientists have this world that they live in, where if you are the first person to discover something, you publish it and you get famous. What happens to the second person that discovers something? They become lost and unsuccessful and ruined because they can't do anything. There's only one discoverer of things. So these people tend to be very paranoid about being scooped by other people. I find that I am not really, at least I know when I do my research, I think it's true, frankly, for most of the people in computer science. They are less concerned about other people getting in ahead of them, because usually there's different ways around things. There's different different inventions, different ways people do things, okay? And it's not quite the same kind of an environment. Any questions about any of this? Comments? Finally, one other thing that I will say is that I found that scientists tend to be comfortable with the idea that data has errors. They know that they are measuring stuff that in their laboratory. They know their graduate student might have accidentally spit in the test tube, or that they didn't clean it right, or they spilled something, okay? Whereas I think the computer scientists tend to have programs that are very, very rigid. Well, kind of we think about data as having to have a prescribed format. So long as it has the prescribed format and it doesn't crash our program, we assume the data is right, okay? And that's something different in this world. We have to be sensitive to what the limitations of our data sets are. Any questions or comments or discussion?
So about data and it having errors, do you mean in terms of noise or the fact that CS does not look at generalizability?
Okay, so first of all, noise is a good thing. So noise, again, there is noise in data, okay? Typically things are experimental measurements. There are biases in data, okay? What the data set means, okay, may mean something different, okay? If you want to figure out who's going to win the presidential election and you are only asking people who are on Stony Brook campus, you may find that that's a problem because you've got a very biased population, a very, stuff like this. So I think that, a good, real scientist, when they think about their experiments or when they're analyzing a data set, they are thinking very hard about what are the real limitations of it. Whereas I find that at least culturally, unless people get sensitized to this, computer scientists to say if it's the right format, I can run it through an algorithm, I will get an answer, and that's good enough. Yes. Any other questions or comments, discussion?
Yes, Professor. Building on that, so the entire point of this is to compare how computer scientists and real scientists operate, and for computer scientists to strive to be more like real scientists, right?
Yeah, today, I mean, computer scientists, again, being a computer scientist is a good thing. You probably get a higher salary than the real scientist, okay? There's a lot of good things about being a computer scientist. But I think for the purposes of today, of this course and this world, and just for, breadth of intellectual thinking, it's important to sensitize you to that the world that this class is going to be in is going to be touching the world of the real scientist, okay? And so I think it's important that we kind of try to think like real scientists in here.
So, Professor, if I may, I'd like to use two examples to put my point forward. So let's say there's a scientist who's working on string theory, right? And he's going through the math, he's going through the data. And while going through data, he comes up with a unique way of finding a new element of sorts, just considering the case scenario. So in that way, he has discovered a new element, which is in chemistry, right? Which essentially is a discovery and has its own importance. But when it comes to data scientists, aren't we more problem driven? Like, for example, let's take the presidential election. So my job is to find out the emotions of the people going through social media polls or whatever. So even if I come across something new from that data, if it's not related to the presidential election campaign, it's not of any use to me, right?
Okay, so there's a question here. I think what this is about, first of all, it's good to have a question in a discussion like this. Sounds to me like you're talking more about the difference between open exploration, exploratory data analysis, and some kind of driven hypothesis kind of testing thing, okay? Yeah. In one world, if there is one thing and one thing only you care about, okay, then you're living in a world of trying to prove a hypothesis, okay? But often you're given a data set, you're given a world, and you want to, you need to understand it better, okay? And, a good data set should suggest, and a good analysis should suggest more questions than just what you came in with. So there is a difference between what I will say a hypothesis testing and a, exploratory thing. And I'll argue scientists do both things. The scientist is trying to discover something. They have something that they're interested in. But a good scientist is going to recognize when they see something that is different, that is interesting, that is not what they expected. And they will veer off in a direction if that's kind of exciting, okay? So I don't see where there's two different things people want to do with data, okay? And two different modes, but I don't see a real contradiction in it. I think that's the kind of thing scientists do.
Okay.
Any other questions or comments? And again, good. I'd like to have a discussion. This will be a very long semester if we don't have such kinds of discussions. Okay, good.
Professor,
Yes,
can we back to last slide?
yes. Let me go back last slide. Boom.
Here we talk about the real scientist, and this is kind of obscure. What is the real scientist? Is the mathematician?
What is a real scientist? In this definition, a real scientist is a scientist that isn't a computer scientist. Okay, that's maybe the way that I'm using this kind of thing. Okay, so computer scientists are, again, culturally, computer science comes from many different fields, which is many different traditions. There's an engineering aspect to it. There is a theoretical or math aspect to it. It's less clear that there's really a science aspect, at least traditionally, of it. You know, there wasn't, you know, people didn't do experiments really to study the properties of computers. Okay, so there's less of a tradition of this than there is in other fields. And I guess the whole point of the speech today is to realize that we want to try to live in a world where we were respecting data and trying to do things with it.
Okay.
Okay, and again, another way that I think of something that's a little the difference between a data scientist and a software engineer. Okay, software engineers, I will argue, you're hired to produce code. Okay, you are hired to build a working system. Okay, that is what a software engineer does. Data scientists are kind of sort of hired to produce an insight into something. You know, again, I will claim that in data science, you're trying to learn something about a particular domain. Okay, you're trying to beat the data till it talks and will tell you something about that domain. Now, I will claim that there's two different ways of thinking about two different ways of superior thinking. One of them is genius, and one of them is wisdom. Genius is kind of, I think, of the algorithm designer who comes up with this amazing thing out of their head. Whoosh, this is the way that you solve the traveling salesman problem. That is genius, okay? Wisdom is about kind of understanding the world and coming up with a good, you know, a good and sound judgment. And what I would say is that there's a little bit of a difference here in data science. Okay, wisdom is, I will say, arguing more about avoiding wrong answers than finding the single best brilliant answer, okay? Genius is about that sudden flash of insight that tells you everything. Data science, I think, is one that benefits more when you're doing a data analysis. I will claim it is less a process of genius and more a process of wisdom. It's about learning where there are mistakes that can be made and learning to avoid these kind of pitfalls, okay? And so, you know, wisdom is kind of the way I want you guys to be thinking. When you're doing analyses, your goal is probably more to avoid dumb things in your analysis than to find the single best way of doing something. So where does wisdom come from? Well, I like to think wisdom comes from experience. So as you get older and your brain gets softer, sort of like me, okay, you like to think you have an experience of what you call it, of the world. You've done a bunch of things, and you can kind of draw on that. Wisdom comes from, in my mind, general knowledge. The more things you know about, the more likely situations you've encountered. You know, I think that this is one where having a broad background is better than having a very narrow background that you know everything in the universe about. I think wisdom comes from listening to people, okay? That you know, hearing what people are saying and trying to learn from that is a source of wisdom. And it comes from, you know, understanding some level of humility about understanding how often you're wrong and why. You know, one of the great things that one of the things that in my life was, I think, a great learning experience was at various points I've gotten involved in saying, hey, wouldn't it be great to build a program that could do some prediction of things that could predict who's going to win a sporting event, and then I can bet on it and make a lot of money, okay? And one of the nice things about making predictions is that you discover how often you're wrong, okay? You can be sure you're right, okay? You can say, my God, this team's terrible, this team's great, okay? And discovering how often you're wrong about things is an important thing to calibrate, okay? And so with this part, I guess I'm trying to encourage you is to try to, use your experience to avoid mistakes. That's kind of, I guess, the system that I want here. Any questions or comments here? And again, this is fair to push back on anything I'm saying here.
Oh, Professor, I wonder how often do people report on what they've found themselves to be wrong rather than right?
Right, so there is what I think you're talking about is there is in the scientific literature, there is a well-known, what they call, I think it's called the discovery bias, which is that when you do an experiment that proves something, you write a paper, that confirms, you have a hypothesis, you believe something, you do an experiment, it shows that, you get a statistically significant thing, you write a paper about it. When you do an experiment, when you have an idea, you do an experiment, you do the statistics, and your idea turns out to not be supported by the data. Usually you slink away, you put it in the results in the garbage, and you move on. And the trouble with that is kind of that in general, people don't get an idea of how often things don't work, okay, and what doesn't work. Okay, and that's kind of one of the concerns here. We should be sensitive to the fact that, why we are wrong and understand why you're wrong sometimes. Any other questions or comments?
Hi, Professor. So in terms of making mistakes, is there another way to make a smart mistake, like calculate the risks of mistakes, or you just explore?
Well, some of the stuff we'll talk about in this class is going to be about what kinds of things you need to do of techniques that make it less likely to have error, that are more robust to things. One thing to say is to realize part of it is to have a suspicious mindset and to recognize that you're likely can be wrong in many things. Okay, that's one healthy thing. There's other aspects about to a certain extent, well, actually, maybe there's other aspects of this kind of thing. But one thing that, just for now, I guess the general thing, as I say, is one should be defensive, one should be suspicious, one should be humble, okay? And, really think if this is, what kind of problems might result from an analysis, okay? More than that, I'm not sure I have a sweeping thing to say about. Any questions? Okay. Fair enough. One other thing that I think is true about data science is that a good data scientist, I will say, is curious about the world, okay? And that they're especially curious about the domain that they are working on. Again, there was this question the first day of class, what's the difference between data science and machine learning? To a certain extent, machine learning breeds a culture of, give me any data set, I'm going to pass it through my network, and I'm going to build a model, and it's going to get a great score, okay? I do think that it is important that when you're, working on a problem, to be curious about what is going on, okay? What is it about the world? I find that when I am, working with a scientist or a social scientist, I'd love to ask them dumb questions about what they do and why. You learn things by talking to them, okay? And I think that's got to be the mindset of what a graduate student, a good graduate student, and what a data scientist should do. I also encourage everybody to read a newspaper. And again, the world is different than when I still subscribe to a paper newspaper, which I know almost no one in the world does these days. But I do think that it's important to make sure you understand what is in the world, what is happening in the world, not just the front page, but it's kind of important to get a broad perspective on the world. The more things you know about, there's this thing in networking called Metcalfe's Law. Has anybody ever heard of Metcalfe's Law in networking? Okay, some of you studied computer networks. Metcalfe's Law was kind of like Moore's Law idea that the value of a network grows quadratically in the size of the network. The more people you have in your social network, the more potential connections you have. The potential networks grow, connections grow n squared with the number of people in it. And likewise, the more things you have in your brain that are seemingly on diverse and different subjects, the more likely a new thing that comes along is going to bang against one of them, and there's going to be some kind of a connection. So I strongly encourage people to, read a newspaper, have a broad perspective on the world, try to be interested in things. Any questions? And again, this may sound like I'm, lecturing and shaking my finger at you rather than teaching, but it is, I think, a mindset that's important. Any questions or comments?
So in terms of a newspaper, I found that, like in the United States, there are Wall Street Journal, New York Times, or there may be a set of buyers. So that says to combination of newspaper to have a neutral way to view their newspaper, what to want to present.
Right. So there's questions when I say what newspapers there's a couple. I will say newspapers get measured on two axes. If I would, maybe I'm just speculating. One of them is a general quality and depth of reporting. Is it talking about serious stuff or fluff and less serious stuff? And the other is the dimension of political bias. I do think it's important to read newspapers that are, quote unquote, good newspapers, okay? Things like the New York Times, like the Wall Street Journal, okay? There's a news magazine called The Economist that I read. That's a weekly thing, and that's actually a very good thing. And you do want a diverse group of political opinions, but a lot of the background knowledge you get about the world is not really political. I mean, it feels like these days everything is political. But if you read a newspaper, you will learn about lots of different things that are, you'll learn about science, and you'll learn about engineering and history and a lot of different things from feature articles and things like that. So yes, it's good to get a good political mix. It's also good to pick good sources. And I think that if you get in the habit of that, that will serve you well over your life. Any questions? I'm not grading you on this, but I think that that's an important thing.
So, Professor, in the difference between machine learning and data science, so for machine learning algorithms, we use performance to know if our algorithm is working right or not. So what is the evaluation process for a data scientist? Like,
Okay, so one thing that is true is that if you're taking machine learning classes and doing research in machine learning, you are very, very comfortable with the idea of evaluating against a score. Okay, that there is a test set, there is a training set. You're going to train on the training set, and you're going to see what score you get on the test set. If the guy next to you gets an 89% against the test set and you get a 90%, you're the champ. Okay. In a typical world, when you're analyzing data and trying to build a system and things like that, it often isn't quite as simple as trying to get sometimes it reduces to, okay, I want to make predictions of whether this person is going to buy or not. Okay, I take a bunch of transactions, I hold some out. Can I predict which customers are going to buy and which ones aren't? Okay, so yes, that in some sense is a machine learning problem. But I think that it's still that understanding something about why people buy things. Okay, why do people buy your products? Why should they buy your product? Okay. You know, I think that you will learn, you know, there's ways of getting insight into your task that I think that the purely machine learning person doesn't do, okay? And I'm trying to, you know, and maybe, you know, the computer scientist who hangs around machine and learning people thinks they lose face if they go and deal with the specifics of an application. I think that's the right way to be doing it. And I think in the context of understanding, you know, why people care about the result is kind of important. Okay, anything else that's important? I'm going to move on. Okay, so one thing that is, I think, very important for a data scientist is that they learn to ask questions. I think that software developers are in some sense, and maybe again, maybe I'm you know, blurring the world a little bit. I will say they are not really encouraged to ask questions, okay? There exists a class of software developer that is given a specification, is dumped on their desk, and they say, build this. Well, why do I want to build this? Doesn't matter why. They're paying us to build this, okay? So if you think of the world as coming from a specification and your job is to build something that satisfies that, you're not encouraged to ask questions. But I do think that data scientists, you know, kind of the world of a data scientist is the world of people who ask questions. You know, if you have a data set, what can you do with it? What might you want to, what could you possibly learn from it? You know, what do the people really want to know? Okay, if you have something you want to know, what data set can you use to get there? Okay, so what I want to do now is devote the rest of the class to the challenge of how do we ask questions or practicing asking questions. I've got 4 different data sets that I find kind of big, exciting data sets. And I want us to sort of discuss them as an example of what a big and exciting data set is. And then see if we can ask some interesting questions about them. Okay? So let's start with, I told you, I guess, last class you had to learn all about baseball and become a baseball fan. You don't have to be a baseball fan in this class, I assure you of that. But the first data set is about a data set that I find is surprisingly big and rich and interesting, which is the collected mass of statistics about all the people who've ever played baseball. Now, for those of you who are not familiar with baseball, but you are familiar with cricket, you know, it's the same kind of thing. You have individuals hit a ball, they run, they try to score things and get points. But what does the baseball reference database have? Well, first of all, it is a record of every player who has ever played baseball. By now, there's probably been about 30,000 people in the world who have played Major League Baseball over the last 120 or maybe even 150 years, depending upon when you want to start it as counting. And for every baseball player, they know what their name is. If you look at the other statistics, they know what positions they played, whether they batted or threw left or right-handed, how big they were, when they were born, what school they went to. We get information about salaries. Okay, their salaries over time. Okay, we get information about trades they were involved with. Okay, it's sometimes possible to trade a baseball player from one team to another. It's like maybe if I have 3 good systems students in my class, maybe I can trade them to Princeton for 2 great theoreticians. Okay, you know, there are these transactions, and it tells you who the players were, what the teams were, who got what. What else does this data set have? For each player, it says how did they play, how well did they play every season. So Babe Ruth happens to have been a very great player, maybe the greatest, probably the greatest player ever. Think of him as a Sachin Tendulkar of Major League Baseball. And this tells us how many home runs did he hit every year? How many hits did he get? How many walks? All the basic statistics. What were their averages? The dark print is telling me, the bold is telling me that they had the best, they were best in the league in that category. So if you look, Babe Ruth was a really great baseball player. See how many times he has bolded under home runs, how often he led the league in home runs, how many led the league in walks, things like this. Okay? So this is what the, the baseball data set has. My question now for you guys is, what can you do with it? Can anybody think of any interesting questions or any questions that you might be able to answer by using this data set? Now I'm turning it over to you guys.
You could look to see and maybe draw comparisons. You could do a classifier, say better or worse than Babe Ruth, and see how players stack up against the grade.
Okay, so there's ways you could build some kind of function to score how good a player is. Could you reduce a player to a single number? Like we're producing, all of you students are ultimately reduced to your GPA or something like that. Could we reduce every student to every baseball player to a record of how good a statistic of how good they are? Okay. Any other ideas of what you could do with a data set like this?
You could ask if you could predict a player's improvements over time.
That's actually an interesting question. Can I predict if I know a player, if I know what the player's record is up until through their third year, can I predict how good they're going to be? Remember, they're making these trades between teams, right? If I could predict how good a player is going to be based on how they've done in their first couple of seasons, I should trade for the players that are going to be good, and I should dump the players who are not going to be so good. Okay? So can I make those kind of predictions? I have a data set here. I have every player that's ever played. I probably do have some insight into that. Any other ideas of what I can do with a data set?
We could also sort of map how performance of different players changes with their age.
Right. So one question that is true is players do not, what happens to players if you had to plot a trajectory? Let's see if my pen actually works. If this was age, I like to make these kind of graphs, and this was performance, what do we think that the average player's, trajectory of performance is going to be over their career? Okay. One possibility would be, I will say that, well, actually what I know, I guess I'd say is probably what happens is they start out, they're, young and strong, but inexperienced. As they get stronger and more experienced, their ability goes up. Then as they get old and broken down, their ability goes down. So there is probably some kind of a curve, some kind of a trajectory of how do players age, okay? And I claim that that's something that's interesting to figure out. Probably that's somewhat it's true about most physical things, and you would learn something about how people age. That I think is kind of interesting. Anything else you can do with a data set like this?
You could determine contract prices.
Determine contract prices. So now you're telling me that, wait, these guys are being paid. Okay, I'm kind of curious. Can you predict how much somebody should be paid based on their performance? Okay, so what is it that determines what somebody's salary should be? Okay, is it that people get paid what they should, or is it that their salary lags their performance? That I get paid for what I did last year, or am I going to get paid for what I'm going to do next year? Do people predict, let's say, what my performance, am I getting better or worse? And so trying to predict and study what the salary dynamics here. This is an interesting record of salary dynamics. It tells you not only do you know what their salaries are, but you also know what their performance is. If I took a look at you guys, what's going to be your salary over time? Right now, probably you're earning, very little. Okay, I mean, because you're graduate students. Presumably at some point you get a job, you're gonna get a starting salary, that's gonna be good. And it's gonna go up. And what's gonna happen? Is it gonna keep going up as you get older? Or is it at some point they're gonna realize maybe you've burnt out and you're not, there's data on it, but there's on your salaries, but there's probably not as much data on your real performance. And this is actually kind of interesting. It's a way of studying real performance versus salary dynamics.
Professor,
Yes.
I'm also curious about the team dynamics. For example, perhaps in baseball, do they score more because their teammates pass the ball to them more often and therefore they had more opportunities to shoot?
Okay, so there are some quite interesting questions about team dynamics. Is it that people do better on certain teams? Okay, you know, how much does the team affect your performance? So one thing that I happen to know as a baseball fan is that if you are a big slugger and you're a tough hitter, okay, if the person after you in the batting order is not very good, what are they going to do? They're going to try to walk you, or they're not going to try to give you good things to hit, because they know that if they can get past you, okay, that the next guy will make out. But if the guy after them is a big star too, then you're going to get much better pitches to hit. So there's certainly dynamics of how good you're going to look on this as a function of what team you're on and how the teams behave. So yeah, I think there's a lot of interesting things you would learn about teams.
Adding to that, maybe the people who build the team can use this data to get the best of the players in their teams.
Right. So one thing that is an interesting trend in baseball, and I'll have to tell you as a fan, I'm not something I'm so crazy about. Now the executives of all the teams, every one of them, they used to be these guys who had, you know, kind of grown up. They were old players and they were, you know, worked their way up. Now the people who run these teams, or you know, a lot of them are basically the same kind of people who run hedge funds. They're sort of smart quantitative analysts. And one result of this is that you're right, they're trying to figure out, how do I pay for the least for the most performance? And there's some ways that, in, you know, as a baseball fan, actually the quality of the product has gotten worse as people have kind of optimized this. They're so optimizing for performance that certain things that made baseball interesting are less obvious. Again, if you're a baseball fan, I may be talking about, you know, it used to be very exciting to watch the starting pitcher. People became, the famous players were the starting pitchers. And starting pitchers got a lot of money. They were the big stars, so people, they had to get paid a lot. Now they've been replaced by an army of kind of fairly anonymous relief pitchers who can throw very hard for a little bit of time, but their careers don't last long enough for you to know their names and their personality and things like that. So anyway, so yes, it's clear that that would help make a team thing go. Any other questions that come to mind about what you could learn from a data set like this?
Also, the coach of the player can use the data to improve the performance of the player because they have the details of how the players have.
So certainly the teams go and look at this data and tell, the teams have gotten very data driven, and certainly they will be able to tell you, Harry, you seem not, you always seem to look at the first pitch instead of trying to hit it. Why don't you, according to our statistics, if you were more aggressive on the first pitch, maybe you'd get more hits.
Yeah.
Okay, so I'm sure that there is that kind of analysis. Anything else that comes?
I was thinking that there is a transfer fee involved when a player moves from one team to another team. So the buying team pays a certain price to get the team from the selling team.
Right. So the question of evaluating these trades.
Yeah,
okay?
exactly.
When is a trade going to be good for your team, and when is it going to be bad? That's part about making predictions of how good these players are, how much they're going to help you,
and how much you should pay actually to
and so
get
how
that
much
player.
you pay. So these kind of things, yes, I claim that a lot of that is encoded in the data. So okay, so we've got a bunch of questions. I would say that much of what came up are baseball questions. And these are some examples of baseball questions. And most of these, I think, were actually discussed. What's more interesting to me is thinking about how you can use a data set in a way that isn't just, what you call it, about baseball particularly. So one of my favorite studies I ever read about studied whether or not left-handed people live longer or shorter than right-handed people. Now, how would you do a study like this? Let's stop. That seems like an interesting question, right? How would you do a study like this? Well, there's a lot of records on when people, how old people live, how long people live. But there are very few records about whether they're lefty or righty. Do you think there is any record on earth about your great-grandfather and whether they were left-handed or right-handed? I would say probably not. So how could you study this question of lefty versus righty lifespans? Well, in this baseball data, they do care about whether you throw left-handed or you throw right-handed. So for these 20,000 people, okay, in the database, they do know whether they're lefty or righty. They know that this data has been collected for, 150 years, plenty of time for people to die, okay? So in fact, there was an interesting study done on whether or not lefties live longer or shorter than righties based on the baseball data. And it came out that the lefties had trouble. Lefties didn't live as long. Okay, now I'm lefty, so I'm not really happy about this, okay? But, there's questions of, again, is this methodological bias, okay? It is true that this is only men. It is true that it's about people kind of long ago, and maybe lefties used to have more things like that. So anyway, this is, I claim, an interesting thing. And again, there's a question on the chat that's interesting. Could you have done this with Army data? That's actually might have been an interesting data set. I can believe Army data records do keep track of whether you're lefty or righty, okay? So maybe that's an interesting way of doing this kind of study, okay? That's the kind of thinking that we like to think about. What other things did I think about? Well, you have a record of people over time. Are athletes getting bigger and stronger? Okay, are they taller? I would think that as a result of better diet, people are probably taller now than the players who played 100 years ago. How often do people return to where they're born? That one thing it had is where did people born and where did people die? In the middle, all these players went off to the big city to go to play. They had big careers in big places. Okay. I claim that there's lots of interesting things you could study with this data set. I think that point is now clear. Any other comments or questions about baseball before I move on to a different set? Okay, let's look at IMDb. I think many of you are familiar with IMDb. That's the movie database. And that has a record of every movie or TV show that's ever been made, okay, by some, at least that they're aware of. This is the data on a movie called A Wonderful Life, which I'll tell you is the only Christmas movie worth watching. What is it about? Well, it tells you what is the title. It tells you when it was made. It tells you what were the ratings from people who've seen it. How good a movie is it? It tells you a summary of the story. It tells you who the director was and the writer and what was the cast. It tells you whether it made money. Okay, there was the box office stuff. It tells you how long the movie is and stuff like that. Okay. And there is also data about each individual actor. Okay, Jimmy Stewart. How many people know Jimmy Stewart? Okay, he was the Tom Hanks of his day. But what do we know? We have when were they born? When did they die? What movies was he in? In the movie, what was the whole cast? Stuff like this. So what do we do with this movie data? Okay, if I give you a database of all the movies, now I'm getting back to you guys again. I give you a database of all the movies and the actors in it. What can you do with it?
can we find out the if we see that which kind of movies are doing well in 1 year or some 10 years, we can see what kind of people lived in that time. They like action more, or
Okay,
they
so
were
one question that you
something.
could see is something about taste in movies, movie genres, okay? What movies were, how popular were movies in each genre in each year? That's a perfectly fair thing. There existed a time when westerns were cowboy films were big in the United States, and that's no longer true. So yeah, that's something you could study. What else could you do with this?
You can maybe also, so looking at all the actors and what movies they've worked in, you can sort of get a statistic which tells how good they are in a specific genre.
So one thing you could try to figure out is, again, what actor has what experience in what kind of genre. So you could imagine there are certain actors who only appear in comedies, and there's certain actors who only appear in horror movies, okay? And that might be something you could learn from this. What else could you learn about?
To learn maybe like a progress of a racial environment, like right now a lot of different like Asian, like black people, they're more into this data and maybe show some racial progress.
So this is now an interesting question. So, there existed a time when all the Asian roles were played by white people with, wearing, makeup, okay? And now that would be unacceptable. There existed a time when there weren't that many roles involving people who were Asian, okay? Could you study let's say, how many movies are being made with Asian actors and with roles involving, Asian roles, maybe names that would be classified as Asian names, okay? That would be actually a very interesting study, to have a graph of representation by race or ethnicity, okay, in different fields, okay? How often was it that the, whether the lead actors were of these things? Maybe you had them, people of color in the background, but it's different, okay? When maybe it was different with respect to lead roles. So yeah, I think that'd be an interesting thing to study. Any other ideas here? I'm looking at something.
I think that we can actually discover what time of a year is good for a particular genre for releasing that movie.
Right. Okay. So what time of year should movies be released? Okay. So
or a particular genre should be released.
It's a Wonderful Life was a Christmas movie. What time should it have been released? Should it have been released in June? Okay. Actually, if you looked at it, it's actually kind of interesting. If I look at this thing, it said it was released in January. Now, January was after Christmas. I can also tell you this movie happened to have an interesting history in that it was not all that successful when it came out. Okay, it was not a very popular movie, maybe because it came out after Christmas. In fact, the history of this one's happened to be, it happened to be the case it was so unpopular, it kind of got forgotten. And the copyright on it wasn't renewed. So that then basically anyone could show this movie and didn't have to pay. And then this movie therefore TV stations started showing this movie a lot and everybody started liking it, okay? So yeah, that seems like a good question here. Any other comments or questions? I see some things on the chat room. Again, I encourage discussion, but what do we see? Is there a correlation between box office gross and ratings? Do good movies gross a lot of money or bad movies gross a lot of money? In an ideal world, I would like to think quality rates corresponds with that, but I suspect that's not completely true. Okay. There's questions about, what is it? Again, trend lines, okay, various trend lines, various emergence of styles, things like that. Any other ideas of questions?
Professor?
Yes?
So based on what is the current age of the actor or actress, we can actually make an observation of how many awards they are achieving. So generally, as they mature in the industry, they get more nominations, more awards.
Right, right. There's actors, actors tend to get, the people get recognized for awards. Sometimes it's because their performance was so great and in one movie, but more likely it's the case that they, people have seen them and liked them for a long time, and they're more receptive to giving them something. So that's right. That's a question of something like that. What other things did you notice? Well, here were my questions.
Professor, I was thinking that about the relationship between the success rate of a movie and certain set of casts working together. So when we can study that from this kind of data set.
So there's some
So
question
if,
of how does the cast affect the success of a movie? How important is it to cast the right actors? What actors work well together? Okay.
Yes.
Sometimes you have actors that work well together, and that becomes interesting. So, like one thing that I find interesting is this idea of the social network of actors. Okay, certain actors work together in a lot of movies. Why is that, or what are the dynamics of the social network? For every movie who were the actors in that movie. You can assume that two actors that were in the same movie probably know each other. Okay, they may meet each other in the course of making the movie. What can you learn about the social network of this thing? I don't know if anybody's ever heard of a website called, at least at one point was called the 6 Degrees of Kevin Bacon. Okay, this may be a little bit old, but someone built the social network of all the actors and then tried to figure out for every pair of actors, how many links removed are they in terms of, my distance to you would be 3. If I made a movie with Harry, Harry made a movie with Bill, and Bill made a movie with you. That's kind of the number of hops it takes to get to you in this network is a measure of distance between actors. And, that it becomes interesting. Certain actors seem to be in the center of this network. There was a guy named Kevin Bacon. There's a more currently, Samuel L. Jackson is supposed to be the most central actor of all. That's kind of that everybody is within 3 or 4 hops of a, if you're a reasonable person, you're within 3 or 4 hops of Samuel Jackson. Okay, so the properties of what this network looks like. How is it that people get jobs in Hollywood? I would imagine a lot of them, they get jobs because they know somebody, and they know somebody because they were in the same movie with them before. Is being in a movie with somebody before predictive of you being in them with movies later on? I think the social dynamics are interesting. What about the age distribution of actors and actresses in films? Do we think that male actors are older on average or younger on average than female actresses? What do we think? Are they the same? Okay. I think that historically, certainly, okay, it has been the case that the men have been older than the women. Okay. That is, they've done studies where, the age difference, whenever you have a husband and wife in a movie that are married to each other, the difference between the ages, okay, on average is pretty high. Okay. Now, this is probably, hopefully, changing with time. But the question of what is the age distribution of actors and actresses, I think, is actually an interesting thing to study. Do we think movie stars live longer or shorter lives than the general population? Who here thinks they live longer? Some people. Who thinks they live shorter lives? Okay, I think I'm seeing more support for, they take drugs, live fast, die young, leave a good-looking corpse type of thing. Okay, actually, I'm seeing longer and shorter here. Okay. This is the kind of thing that if you have a database of all the actors and actresses, this seems like something you can study, okay? And And is the answer different for big stars rather than bit players? Okay. It may be that if you are a star, you get into a terrible lifestyle. Or it may be that the stars live healthy, they get rich, they can afford good doctors. This is the kind of thing you can study. Any other interesting questions about what you call it? So there's questions again. The question is it about lifestyle choices? Is it about access to wealth? Okay. I claim that there's interesting dynamics here if one wants to study it. Anything else lurking in the movie database that you guys can see? Okay, good. Let's move on to another one. So Google Ngrams, I actually talked about this on the, in the first class, is this data set that is, I think, kind of really amazing, that you actually can get access and download into a lot of the data. Basically, they took every book that Google ever scanned, and they broke it down into every phrase from 1 to 5 words long. And they give you a time series for every popular phrase, every phrase that occurred at least 40 times. How many times did it appear each year? Okay, that's what Google Ngrams did. So if we remember something like this, okay, what does this show you? This shows you how often did Frankenstein, Albert Einstein, and Sherlock Holmes appear in books published between 1800 and 2000. What does it look like? Albert Einstein was never mentioned in scanned books before about 1900 or so. Why is that? Can anybody think of why they didn't talk about Albert Einstein before 1900?
Because he discovered relativity after that.
Because he wasn't worth writing about until after he was famous. And obviously before he was born, he was certainly not worth writing about, right? And what about, what else do you see from this graph? Any interesting things with this graph? Why did Frankenstein suddenly start to become popular? If you look at it, I see a sudden jump in how much I talk about Frankenstein around 1970 or so. Why is that?
It could be an interest in extra horror movies. They probably put out a horror movie for
Could
Frankenstein.
be that there's more increase in horror movies. Is there any other reason?
And sci-fi started to become
Sci-fi,
popular at that time.
maybe different genres changed? Is that it, or are there other reasons? My instinct is Frankenstein kind of became a adjective almost, okay? That Frankenstein was kind of the metaphor for the scientists doing crazy things and creating, big monsters and problems, okay? And I think that that's probably why. It kind of got another use to it, okay? But anyway, this is an interesting thing. For every phrase, okay, that's ever appeared in books, you can follow how much it's talked about over time. So if you have this kind of data set, what can you do with it? Any ideas of what you could do with a data set? Charting how often things are talked about in books.
I think maybe the word changing, if it's the same meaning, but the word changing with during the time.
When do words change meaning? Okay, so maybe you could get some ideas about word meaning. Certainly you get ideas, changes in word usage. Okay, yeah. When does a word become popular versus not? When does a word created? When was a word first created or not? Okay. Maybe you can learn when a word changes meaning. The word gay when I grew up was supposed to mean happy, okay? And the word has taken on another meaning since then, okay? And could you measure that? Well, certainly you could measure the frequency. And maybe there's ways of measuring the meaning, although that's less obvious to me. Well, I mean, actually, you can, but that requires some more thinking. What else can you do with it? Anything you could do with knowing about the frequencies of which things are talked about in books that become interesting?
As you had mentioned in the previous lecture, the ranking of the figures. So finding out the
So if I wanted to try to find out which people are most important or interesting or famous, one measure is how much are they being talked about, right? So if I took a look at all of the data from this, pulled out all short phrases that corresponded to names, okay, and then looked at that, I could tell who are the most famous, most talked about people at any given time. That would be an interesting thing to know about, okay? Why are, yeah, and then you could play around with questions of why are they being talked about, okay?
Can we find semantic relations between the n-grams, like each n-grams from this chart graph?
Semantic relate, again, you've got these standalone things, so you could figure out about, let's say, words that appear in the same n-gram. So for example, suppose I wanted to find out what colors of cars are most popular, okay? You know, are there colors people don't paint cars? I'm now kind of speculating here. I will claim that there are a certain number of white cars, there's a certain number of yellow cars, there's a certain, well, you could look at how often the phrase white car, yellow car, green car, blue car, red car appear. And that would probably give you some kind of idea of this. You would learn probably what is an adjective because it modifies a noun. So there's some semantic stuff you could probably learn about these words. Okay, again, you only have very short phrases, but you've got a lot of them. You have all of them that appeared in books. So that might be very interesting.
adding to it, we can also find relations, as in like Apple and Steve Jobs occurring together for a lot of times.
So the question is, could you find associations between things? So you're saying the phrase Apple, President, Steve Jobs, that's 4 words long. Maybe that would be enough to make that kind of a linkage, okay? So you could do that from, you know, possibly from these things. Again, the fact that the good thing about this data set is that it has everything in books and it has it earmarked by time. The bad thing, it's only popular short phrases, okay? And so it's not clear to me for something like that whether you're best mining this or something else. But maybe that tells you something. Any other ideas of things you could learn from looking at these n-grams?
A quick question. I wonder if the variety of n-grams have already been accounted for. Perhaps toward recent years, the variety of words being used increased.
Okay, so there are interesting questions about vocabulary sizes over time. Are vocabularies that are appearing in text books these days, is the vocabulary size increased or decreased? Did people 100 years ago have more, you know, use a bit bigger working vocabulary than they do now or not? Okay. That kind of thing is presumably inherent in here. Any other questions?
You could compare this to market data or other news sources to view cultural trends or technological trends. Like, for example, you could see exactly when the VCR started to die.
Right, so there's a question about technology trends. You know, when did VCRs, were people talking about fax machines and VCRs or telegraphs? Okay, and so yeah, so that kind of thing. So what kind of questions might I have been interested in what you call it, you know, using the n-gram corpus for? Well, actually, the one that just got asked was basically the second question. How is it that technologies are changing? It was a very interesting study done about how much how much shorter the lifespan of technologies is today than it was 50 years ago. That, you know, the telegraph was a big deal for, you know, 80 or 90 years. The telephone was a big deal for maybe 50 years. You know, the cell phone will be a big deal for 30 years. Maybe then direct brain implants or something like that is going to take over. Okay, what is the lifespan of technologies? You could figure that out. The first question, how much cursing is there over time? You know, some of you, I suspect, know some dirty words, okay? Is the use of dirty words increasing or decreasing over time? Okay? It's hard to get a handle on how much people cursed 100 years ago. But we can say how much did people curse in books 100 years ago, because we've got the scanning, right? So this becomes an interesting study, okay? It's probably this kind of study where bias in the data makes a difference, because these are drawn from books that were sitting in libraries, probably at universities. My guess is there was less cursing in there than in, you know, in maybe books that the average person saw. So, okay, there's all these kind of things. We've seen about using this as data to build language models. This is a very important thing. If you start looking at word embeddings and, you know, and NLP language models can be trained on this kind of data. Any questions about n-grams? Let me give one final data set, which has to do with New York City and taxi drivers, okay? I don't know how many of you, again, we live in this time of when life has been shut down. I don't know if how many of you have gone to Manhattan recently, but there exists taxis, these yellow taxis that drive around, that pick people up, and I'm guessing many of you have ridden in a taxi before. One interesting thing is now taxis are instrumented, and that there's a database of every single taxi trip that has been assembled by the New York City, and you can obtain this data by filing a it's actually now on the web, but originally they got it by filing a Freedom of Information Act request, meaning that they said you're a government has to release data if it can. What does this data set tell you? It tells you for every ride, what was the taxi that was used? What was the driver that was used? Okay, at least they give you their ID numbers. They tell you when was the pickup, when was the drop off, how many passengers were there, how far did it go, where did it go, from where to where, okay? What could we do with this kind of data? When I looked at it, I had something like 90 million trips, okay? Probably now you can get 200 million trips. What could you do with knowing the complete set of pickups and drop-offs of taxis in New York?
One thing you can do is you can look at all the pickup spots, and like if you see the frequency or how it increases, and
Where is it that people pick up taxis?
Yeah.
Okay. Do they pick
Yeah.
up taxis a lot outside of Penn Station? My guess is probably yeah. Do they pick up people a lot outside my apartment? Not nearly as much. Okay. So where do people get picked up, and where do they go? Where they go are probably going to be tourist destinations and things like this. Okay. So yeah, I think that's probably something you could figure out that's interesting. What else could it be done?
How does the fare change across different times of the year for a same route?
Okay, so the question is, if I go from A to B, how does the fare change? You say, oh, as a function of the year.
Yeah.
So I imagine, I am willing to bet you that taxi rides were a lot faster during the pandemic at the very beginning, when everybody was shut in and all the offices were closed. Then basically, that's great. You make great time. There were no traffic. So certainly as a function of traffic and probably weather conditions, when it's snowing, the taxis don't move very well.
Yeah, also
Okay?
like festive seasons, like probably when people are more out, the fares might go up.
So there's other dynamics of what are the fares. Now you guys live in an Uber world where there's this demand pricing. The taxis in New York sort of have fixed rules as to what they can charge. So there's a limit to how much they can grift off of people if there happens to be a lot of demand. Okay?
Yeah.
But there are certainly probably some pricing dynamics you can figure out. Anything else about taxis?
What's the
about
best-
world or taxis or the city? Anything you could learn from this?
We can see the inflow and outflow of the traffic so that the
They
traffic
can't hear you.
congestion. Hello. So
Yes, I hear you. Hello? Any other questions or comments? Ideas?
You could try comparing the volume of pickups during different times of the day.
How does the time of day make a difference? You know, people presumably they go to work at some point. There's a time when people are going to work. There's a traffic pattern from that. There's times when people are going home. There's times on weekend when they're out having a good time. Okay. What would we learn from this kind of thing? So what were the questions I asked about? I was kind of curious about taxi drivers. How much money do these guys make? Is it a good business or not a good business? Okay. I don't really know, but I'm curious. Okay. How much of a variance is there in this? Is it that some taxi drivers are smart enough to go in the right place and other taxi drivers aren't? Okay. How much driving do they do each night? You could also view this as a sensor for how much traffic there is as a function of time. I'm going to argue the main difference between how long it takes to get between point A and point B is going to be about the traffic. Okay. There's questions about tipping. Okay. One thing that these records do is they let you know whether you can award the driver extra money because they did a good job. Give them a tip. Is it that the faster drivers get tipped better? Okay, that seems like an interesting question. Usually, at least you see in the movies, you get that the guy gets in a chase scene, they get into the taxi and they say, go follow that car or get me to the church as soon as possible. Okay, do they show gratitude when people drive faster? And where should there be more taxis? Because there's more people to pick them and where should there be less taxis? These seem like interesting things to know about. Any other ideas of what you could do with a taxi data set?
Like urban development, like if some a new area be developed, more taxis will be there, more traffic.
So there are probably interesting questions of what kind of people are living in a particular place, what kind of trips are being taken there. Does this shape what you should do? It does give you a set of sensors on the city that are very interesting things to think about.
One thing we can add to the same thing is that we can find the property rates or something like that when a new area is developing. The rates
Okay,
of
so
property.
is it that where richer places get more traffic, taxi traffic? Okay, maybe you can tell something about the income level or the density of a region. Okay, something like that. Okay, so there's a lot of these different things. Again, I think that this has hopefully been interesting and instructive. Okay, again, the mindset I'd like people, the developer, to have: if you have a data set, what can you do with it? Okay, and think of all the ways that you could maybe make the data set talk to find interesting things. That's, I claim, one of the things data scientists think about. Okay, any other questions? If not, thanks for your attention, and I will see you all on Tuesday. Okay, thanks a lot.